Hello, Mr. Boytet here. Today, we're asking questions about Earth's interior. The question I have for you is, how do we know what's in there? How? How can you figure out what's in the middle of a giant sphere that you can't possibly get to the center of? There are two real ways we figure out the properties of the interior of the Earth. First, we use vibrations from earthquakes, known as seismic waves. I'm actually creating tiny little earthquakes just by knocking on this wall. And if I do that here, I can tell that about right here, and in the corner, there's a stud. I can tell that there's wood on the other side of that wall just by knocking on it and listening to the vibrations. Similarly, we use these earthquake seismic waves to figure out what's going on inside the Earth. The second way is by taking a sample. If I hammer at this wall over here, hard enough to break a piece off, I can tell that it's made of concrete. And we can go pretty deep with samples, but really only the deepest we've ever gone is only about 7 miles into the crust. And if you consider that the Earth is thousands of miles at its biggest diameter, we really are only getting a tiny little sample of the crust, even with our deepest holes. So samples from holes only go so far. Where else might you get samples from deep inside the Earth? If you said volcanoes, you're right. Volcanoes are areas where magma from the Earth's mantle naturally rises to the surface, helping us know what's down there in the Earth's mantle. Finally, in a lab like this, scientists can simulate the temperatures and pressures one would expect to find deep within the Earth to see how rock behaves and figure out how the inside of the Earth might be behaving that way by simulating it in a lab. So now we're going to take a journey down inside the Earth and look at how the characteristics change as we go deeper. The first thing you'll notice in this mine is that there are huge beams holding up the ceiling because the pressure of all that rock pushing down gets really big. So as you go down, more and more rock is on top of you. So the pressure gets greater and greater, much like when you go to the beach. When I'm buried in the sand, I can feel the weight of the sand putting pressure on my body. As you add more sand, the pressure increases. That's just like going deeper and deeper into the Earth. After a while, all that pressure, combined with some radioactive decay from the rocks, starts to make it really hot. Now, two other things change as you go down. We have the physical state, meaning solid, liquid, gas. In this case, we have either solid or we have semi-solid or plastic, as we say, sort of like peanut butter texture, something in between a liquid and a solid. And then we have liquid. And the other way that things change is in their chemical composition, meaning what chemicals make up the rocks as you go down. So first, we'll talk about the physical layers, or the layers based on solid, semi-solid, or liquid. Layers based on physical properties, or physical layers. The physical layers include the lithosphere, L-I-T-H-O, which is the realm of the rock, so it's solid. The asthenosphere, this is the semi-solid part that flows like peanut butter. Semi-solid, or plastic. The mesosphere, meso meaning middle, and this again is solid. Solid. And then when we get down to the outer core, the temperature gets so hot that it actually turns back into a liquid. So you have liquid rock again, which you also know as magma. But the pressure starts to get so great when you get all the way to the inner core that it literally pushes it into a solid, even though it's hotter than the outer core that's a liquid. So it's so hot, but so squeezed under such high pressure that it's back to a solid. The chemical layers are easier to remember by name. So we just have the crust, the mantle, and the core. These layers are what they're chemically made of. That is the distinction between layers. So the crust has its own composition, mostly oxygen and silicone. The mantle adds a couple other things in the mix. It has oxygen and silicone, but it also has magnesium and iron. And the core, well, the core is iron and nickel. Iron and nickel make up most of the core. So two different ways to think about layers of the earth. So next time, we're going to talk about what happens in the outer core, in that liquid outer core, that gives us our magnetic field. We're going to talk about what the crust is made of, and why lots of you have granite countertops. Hint, hint, wink, wink. And we're also going to talk about how earthquakes can possibly help us know what the middle of the earth is like. Hasta pronto.